Here's some review from rational exponents. So remember, using the product property, 7 to the 1/2 times 7 to the 1/3, we add the exponents. That would be 7 to the 1/2 plus 1/3. You would need a common denominator, so this first fraction I can multiply by 3/3. That becomes 7 to the 3/6. And the second fraction, 1/3, I can multiply by 2/2. So that would be 2/6. And now that they have a common denominator, I can add them, and that would be 7 to the 5/6. Now, in exponential form, it would look like this. If I wrote it in radical form, it would be the 6th root of 7 to the power of 5. So either one of those are correct, but in radical form, it looks like the latter. To simplify the following, this is power rule. So remember, you need to distribute this power to everything inside. So we have 2 to the power of 4, we have x to the power of 4, we have y to the power of 16, we're multiplying the exponents, and we have y to the power of 4. So I can combine these two things, and then I can simplify 2 to the power of 4 as well. So 2 to the power of 4 would be 2 times 2, times 2, times 2. That's 16, x to the power of 4. And then when I combine these, I would use the product rule, just like I did in example 49. So I would add the exponents. That would be y to the 20th. And then for number 51, because negative 1/3 and 9 both have an exponent of 1, this is negative 1/3 to the 1 power, and this is 9 to the first power, I can actually multiply those together because they both have an exponent of 1. So 9 times 1/3, or in other words, 1/3 of 9, is 3, so that's negative 3. And then if I can highlight, let's see if I can do it small enough to have you see it, the a from this first factor and the a cubed from the second factor can be combined. And then the b squared from this first factor and the b cubed from the second factor can also be combined. So if I combine the a's, I can combine them using the product rule, which means I add their exponents. So a to the first and a cubed, if you add their exponents, would be a to the 4th. For the b's, I have b squared and b cubed. If I add their exponents, I have b to the 5th. For solving equations with rational exponents, for this first one, it's easier if you convert it back into exponential form. So if I convert this to exponential form, I don't like fractions within fractions, so I can give it a new exponent of 1 and say this is 2 to the 3/2. And then if I convert this radical and this power back into exponential form using flower power, I can say it has a power of 1 with a root of 4. Power of 1 root of 4 equals 2 to the power of 3 over x. That's the other side of the equation. Using the power rule, I can multiply these. So this would be 2 to the power of 3 over 8 equals 2 to the power of 3 over x. Well, because my bases are the same, and this is an equation, I can cancel out the bases. Therefore, 3/8 is equal to 3 over x. And I hope it's obvious at this point that x is equal to 8, but if not, you could cross multiply and realize that x is equal to 8. For the second one, up here we were able to cross off the bases because they were both equal to each other. In this example, the bases are not equal to each other, so I can't cross them off yet. However, I can rewrite 27 and 81 as a base of 3. 27 is 3 to the 3rd power, and notice it already has an x plus 1, so let's not forget about that in the exponent. 81 is 3 to the 4th power, and it already has an exponent of 2x. Let's not forget about that. If we simplify what's in the exponents, I have 3 to the power of 3x plus 3, because I distributed this 3 to everything over here. If you distribute the 3 here and here, that's how you get 3x plus 3 in the exponent, is equal to 3 to the power of 8x when I multiply. Now that my bases are the same, I can cross them off on both sides and say that the exponents are equal to each other. Therefore, 3x plus 3 is equal to 8x. To solve this equation, we would subtract 3x from both sides. So therefore, we would get 3 equals 5x. Divide by 5 on both sides, and you get x equals 3/5. All right, and last but not least, this one is very similar to the one that we just finished. Again, the bases are not the same yet, but we can rewrite them. Remember that if you have a fraction that's with a negative exponent, you can rewrite it as 125 to the power of negative 1 is equal to 25 to the 3x plus 1. If I rewrite them, I can rewrite them both with a base of 5. So over here, this is 125 is 5 cubed. So if I write it up here, that's 5 cubed to the power of negative 1 equals 5 squared to the power of 3x plus 1. Again, let's multiply these exponents. So let's multiply 3 and negative 1, and let's distribute 2 to this. So when we do that, we get 5 times 3 and negative 1 would be 5 to the power of negative 3. On the right-hand side, we would have, if we distribute the 2, we'd have 5 to the power of 6x plus 2. My bases are the same, so I can cross them off on both sides and say that the exponents are equal to each other. So negative 3 is equal to 6x plus 2. If I try to solve for x from here, we would subtract 2 from both sides. So that's negative 5 is equal to 6x, and then divide by 6. So we can say that x, 6. So we can say that x is equal to negative 5/6.